Good morning, students. Today we will start exercise number 8.2 from NCERT book. But before starting the chapter, we have to know about two formula, or you can say two theorem. In this chapter, main theorem is midpoint theorem, and this related two theorem here. So first you understand what is midpoint theorem. See, I am drawing here one triangle. ABC. Okay. Here this one D is the midpoint of AB and E is midpoint of AC. I am repeating again, listen. D is midpoint of AB and E is midpoint of AC. So the line passing through point D and E, is always parallel to this line, means DE parallel BC, and DE is half of BC. So what we can write? D is midpoint of AB and E is midpoint of AC. Then DE parallel to BC and DE equals to half of BC. So what we learn here? If D is midpoint of AB and E is midpoint of AC, then the line DE is parallel to BC, means this one parallel to this, and DE, length of DE is half of BC. This one is the first theorem. And now we will learn second theorem. What is the second theorem? See, I am drawing here again the same triangle. A, B, C. Actually, this theorem is vice versa of this one. It means if D is the midpoint of AB, then the line passing through point D, I am repeating it again, then the line passing through point D, which is parallel to BC, the line passing through D which is parallel to BC meets the midpoint of AC. It means this line bisect AC, means the line passing through D and parallel to BC is always meet the midpoint of AC. The line drawn through the midpoint of one side. See, in theorem 8.10, that's why it is written there, the line drawn through the midpoint of one side of a triangle. See, here D is the midpoint, drawn through the midpoint of one side of triangle. One side means here AB. The line drawn through the midpoint of one side of triangle AB and parallel to the another side BC bisect AC. means it touches the midpoint of AC, or you can say that this line bisects the line AC. So what we can write now? D is the midpoint of AB and line passing through D and parallel to BC bisect AC. Now we will start exercise 8.2. First question. See what is first question given here. First question is ABCD is a quadrilateral. ABCD is a quadrilateral where P, Q, R, S are midpoint of the sides. P is midpoint of AB, Q is midpoint of BC, R is midpoint of CD, and S is midpoint of AD. And AC diagonal, A to C diagonal. We have to show SR parallel AC, means this line parallel to this line, and SR is half of AC. Second proof is PQ parallel SR, and third one is PQRS is a parallelogram. PQRS is a parallelogram. So step by step we will do. First we will write here S is midpoint of AD and R is midpoint of DC. This is midpoint of AD and R is midpoint of DC. So from triangle DAC, what we can write? Therefore, from triangle DAC, SR parallel AC and SR equals to half of AC. Why we can write this? As AC is the midpoint of DA and R is midpoint of DC. So from triangle DAC, we can say this line is parallel to this line and this one is half of AC. So that's why I am writing here SR parallel AC and SR equals to half of AC. So your first condition proved. Okay, but must you write by midpoint theorem. Now we will see second one, means we have to show PQ parallel SR, but before that we have to show PQ parallel AC. As PQ parallel and equal to AC and PQ is half of AC and SR is also half of AC, that's why we will say that PQ is parallel to SR and equal to SR. So write from triangle ABC, P is midpoint of AB and Q is midpoint of BC. Therefore, by midpoint theorem, what we can write? PQ parallel to AC and PQ equals to half of AC, means PQ equals to AC by 2. Already we have SR equals to half of AC or AC by 2, and PQ also same. So from this and this, what we can write? So now you write here equation 1 and equation 2. So you can write here from 1 and 2, PQ equals to AC by 2 equals to SR. This implies PQ equals to SR. Your second condition proved. And you see here, already you have PQ and SR equal, and you can see here PQ is parallel to AC and SR is parallel to AC. PQ is parallel to AC and SR is also parallel to AC. So ultimately what you can write here, PQ parallel to AC parallel to SR. Therefore PQ parallel SR. You know that if opposite sides are equal, means PQ and SR equal, and if the two opposite lines are parallel, then PQ SR is parallelogram. So you can write here, therefore, as PQ equals to SR and PQ parallel to SR, therefore you can write PQRS is a parallelogram. So your third condition proved. So this one is your third, and this one 2. Okay, I hope you understand.